Hello friends, welcome to our channel. Today I will discuss a new topic, that is instructions cycle with the four phases. Okay, with a certain example and a corresponding diagram. So main topic is instruction cycle with the four phases or instruction cycle with the phases. So before that, that is I will just some explain regarding on what is the instruction and how different cycles or instruction cycles will create with a certain number of phases. Normally, whenever any instruction need to execute, then that instruction go through certain number of phases for execution. Okay, and different parts of instructions are there. Those parts are essential whenever different cycles it needs to execute. Okay, so now we will discuss regarding on this topic. So here which kind of a parts or which how the particular type of instruction need to execute, or what is the process or what is the stages. Okay, before discussing that part, we will see whenever we go through this particular that is type of instruction. Okay, any kind of instruction we can take, it doesn't matter. So the thing that normally whenever write any kind of instruction, that instruction defined under a certain programs. Okay, and normally programs residing in the memory unit of the computer system or some certain part of the computer system, which is consist of sequence of instruction. Normally all of you know that the program is a sequence of instructions. Normally program consists of sequence of instructions, and the program is executed in the computer by different cycle where each instruction need to identify and what is the type of instruction, or what are the parts of instruction need to execute. They depend on that instruction of the program, and each instruction cycle turn into subdivide, or it divide through certain number of phases which are follows. So I will tell you what are those phases whenever any instruction need to execute. First of all, we will that is fetch the instruction from memory, because whenever write any kind of program, under a program the number of instructions are there. So each instruction we have to fetch through certain time period or certain times, then need to operate accordingly. So whenever any instruction need to operate or execute, then number of phases are there. First phase is fetch an instruction from memory. Means you have to fetch the instruction from memory for that is identify what category of operation need to operate. Next, after fetching that instruction, then decode that instruction, because direct that instruction cannot be operated or execute. So second phase it should be decode, because each instruction having different parts. Each part should be appropriate by which computer can execute or compiler can execute. Okay, so decode, after that decode the instruction. After that, that is read the effective address from memory if instruction has an indirect address. Some instruction having some operand where the operand is accessed directly or indirectly. For that reason, we just see that some address having direct address or indirect address of any kind of operand. So we have to read the different time slots are there. So controller read the effective address of operand from memory if the instruction having indirect address. How to know that indirect address? Then some part is there, I will discuss later. And after everything is okay, then going to execute that instruction. Okay, this is the basic concept of phase. That is different phases of instruction. So we can tell as a instruction cycle with number of phases. Normally 4 phases we will consider. First one is a phase and instruction from memory, and next decode that instruction, next read the effective address of operand from memory. If it is indirect, if it directed, no need. Next execute that instruction. These 4 phases are required for any kind of instruction. Okay. Next we will discuss one after one, that is through different phases. First phase we will see that is a fetch and decode. First you see fetch and decode. What happens initially, program counter PC, because each instruction is identified by PC program counter. That means initially program counter is PC is loaded with the address of first instruction. Whenever first instruction is there, then it will find out its address of instruction and it assigned to PC. PC identify particular instruction and loaded with the address of the first instruction in the program, because program contains a number of instruction. So PC identify which instruction need to execute. So initially whenever any program written and after compilation, that is each instruction identified through PC. Okay, like a 1 2 3 4 5 number of lines are there, number of lines identified for each individual instruction. Okay, and next sequence counter, SC, you can tell as SC for sequence counter. Initially it is 0, means not counted, and after there is assigning different parts through certain number of time, then sequence counter will be increased. Okay, for example, whenever I go through first time clock pulse, then PC assigned to that instruction, then PC transfer to the address register of a particular instruction. Then T0 time, what happens? Program counter identify the instruction and transfer to address register. Okay, that is the work of PC and control unit. And at T0 time, means first T0 time we will consider. At the T0 time, what are the instruction statement or number that assigned to address register. This is the first time. So automatically SC will be increased whenever number of times or clock time will increase. Sequence counter also increase, because different time different operation need to operate. So according to that sequence counter also increase. Okay, so first T0 time, you see very simple way. T0 time it is what happens? So providing decoded time signal T0. At T0 time, what are the program counter receive or identify the particular instruction and assign to address register. Okay, particular instruction identify the address register, what is address register or that particular line. After that, it is a 1 T0 clock time. After that every clock time will be increased one after one. Accordingly, sequence counter also increasing. After increasing clock time, sequence counter also increasing one by one, so that time signals go through a sequence T0, T1, T2, T3, T4 as per increasing of sequence counter. And the sequence counter actually used for the time. The micro operation for the fetch and the decode phases can be specified by following register transfer statements. Means whenever sequence counter is increasing, then what will do? They will check that which program counter also assign different statements. Accordingly, the particular instruction also, that is collect from memory and transfer to instruction register. Okay, initially it was in memory and transfer to instruction register. After that instruction register once found that instruction, then it will check is it correct or not, or what to do. That instruction register can decide. So it is done through different sequence counter. Initially program counter assigned to address register for instruction. After that program counter increasing, after next clock pulse, T1 clock pulse, program counter increasing, and at that time what happens? That instruction where is available, that is address register in memory, that instruction transfer to instruction register, because instruction is now available in memory, that is transfer to instruction register means read instruction that is instruction from memory transfer to instruction register means read at a instruction register. This is the basic concept. We have already discussed that part, how it is read or write operation through memory. It means what happens, the instruction register or instruction transfer to instruction register from memory. Okay, after getting instruction register instruction in a instruction register, then it convert that is a decode, that is we use decoding of that instruction, and each instruction having a number of parts. We have already discussed, still that is I will discuss that part. So instruction having number of parts. What is that is one part is address part. We have already discussed, still that is I will tell you. This is a opcode part. Okay, this is opcode part. This is that is I for mode. We can tell as a mode for I. Okay, I if is 0, that is a direct address. If I is equal to 1, that is indirect address. This in this way we can find out instruction is a direct address instruction or indirect address instruction based on that instruction format. Okay, here what happens, since it has a 3 parts, that is a address part, opcode part, I part, all things should be very appropriate, it should be very identified. Okay, after that is a T1 time, next go to T2 time. T2 time whatever decode that particular instruction, because first phase we have already discussed that first phase what happens, it is a fetch an instruction. You see, it is a fetch an instruction from memory, first phase. That means you see, in first phase PC find out the particular instruction and transfer to address register. Address register means keep in a memory, and we have already discussed in a common bus system how memory address register linked to the memory. That part also over. Okay, you can see that lectures how memory address register linked to the memory, and whenever access any data through memory, how it is activated. Here you see fetch an instruction from memory. So PC assign that instruction and assign to the address register, and second clock cycle transfer the address register to instruction register. Here now instruction register contain that instruction. Okay, in that time PC will be increased. But here what happens, whenever you go through that part, then what happens, you see second or next clock pulse, that is a decode that part, whole instruction part. You see, whenever decode that particularly, you see D0 to D7, this is the that is a 7 D7 that is opcode part. Here you see, here is 12. Okay, here 12 bits, 0 to 11, here 12 to 14. Okay, it is a 3 bits, it is 3 bits, it is 1 bits, 12 bits, it is 12 bits, it is 3 bits, it is 1 bits. Total is 16 bits. Total is 16 bits. 16 bits is divided by in this way. One is 12 bits for address, 3 bits for opcode, 1 bit for mode. Okay, either direct or indirect. If I is equal to 0, that is direct. If I is equal to 1, that is indirect. In this particular opcode part, what happens? That is 3 bit. 3 bit means, you know that 3 bit means 2 to the 3 means 8 operation. 8 operation defined through that is D0 to D7. Okay, D0 to D7. That opcode part need to that is a decode, because we don't we write add subtract anything, multiply anything, then that should be decode. So here D0 to D7 it is a decode. Which part? That is a IR in instruction register part, because instruction register contains the instruction. It has a second part, that is opcode part, that is it should be decode. This is 3 bit data for different operation need to that is a decode. After that what happens, during that time what happens, address of operand. Okay, address operand means 0 to 11. Here you see instruction register contains that operand part 0 to 11, that transfer to address register. Okay, that data, that operand part transfer to address register, and I is equal to, here IR is equal to 15. Okay, IR is equal to 15. In this case what happens, you see that IR, how it is find out. IR is just identify, that is what mode. This mode identify indirectly. If I is equal to 0, that is direct address. Okay, if I is equal to 1, indirect address. In this way we can find out that is a this direct or indirect address of that instruction whenever we see. Okay, this is the fetch and a decode part. In this part is a fetch and a decode part. Okay, so here you see in that different time slot, how the different that is a sequence or a time used to access the data from memory or address register or PC or IR. Okay, here you see, I will show you in fetch and decode time what are the registers are used. Okay, what kind of registers are used? Very simple way. One is PC register, one is a AR register, another is memory, another IR. Okay, that is normally 4 registers are used with that is 3 registers. Okay, 3 registers with the memory. Because PC, AR, IR, 3 registers and a memory. 4 components are used whenever we go through any kind of instructions. Very simple way. Other also there, although all the others are there, but simple way we go through this 4 that is registers, 3 registers with a memory. So in that case here very simple. I have already told you very simple way. It is we can go through that. Here we see memory for that is whenever we go through common bus we have already designed. We can see that previous lectures. Memory connected to this 7 because it depends on that 7, that is S0 1, S1 1 and S2 1. Whenever all are 1, then 7 means memory unit we consider. Okay, and here address register also connected to memory. Whenever any data from instruction, the address register that keeps the data in memory and transfer to the memory directly. You see this kind of direction is there. Okay, no problem, and it is activated by 1 because it is as per this common bus, it is fixed here for 1, PC is 2, IR is 5. Okay, not that it is 1 2 3 like this, because we have already discussed that it's different register connected to that certain number. Okay, and that number is decided by this S0, S1 and S2. This is the common structure of this particular that is what we call that is this is one kind of structure through common bus having that is 4 phases. How whenever 4 phases will consider how it is work. Okay, so initially PC, similarly PC assigned initially the instruction, and you see that PC we have already discussed. PC assigned to that address register. You see very simply I mentioned PC assigned to address register. Here PC assigned to, you see PC transfer the data to the common bus, again come to that common bus and transfer to AR like this. Okay, next phase is similarly a memory address register. What happens? It contain the address register, again transfer to here and come to next is a instruction register. Okay, so previously we have a little bit discussed how data transfer from each individual register and transfer to memory. Sorry, common bus and common bus different register, how data receive from common bus. We have already discussed that part. Okay, so this is the basic structure of this what common bus, where instruction cycle will consider. So instruction cycle only, that is 3 register record AR, PC, IR and memory. From that different register they will provide the data to the what individual that is a position 7 1 2 5 like this, and they will receive data from common bus. This common bus they will receive. Okay, this is the basic concept. Now we'll see, since only AR is connected to the address inputs, as per this you see very simple, AR is the connected to the address input to the memory. Okay, this memory, then what happens, it is necessary to transfer the address from PC to AR during clock transition associated with the time signal T0. We have already discussed, because initial T0 the AR receive the data from PC, just address of instruction. This T0 receive the address of instruction. Okay. Then T1, after that T1 will come. Then what happens? Next clock transition, IR receive the, or instruction register receive the that particular data from memory. Okay, as per this particular instruction, that is, you see, AR memory, that data transfer, or that particular instruction transfer to instruction register in T1. And at that time PC also increasing, at that time PC also increasing. So at that time what happens? PC also increased by 1. And at T2 time what happens? Decode. We have already discussed T2 time. What T2 time is required? T2 time is that is what decode. IR will be decoded, and it find out it is direct bit, direct address or indirect address as per the bit. If the bit flip flop is 1, or it is developed through flip flop I. Okay, it find out I is equal to 1 or 0. If 1, that is indirect. If 0, that is direct. So in this way we define that another part. Okay. So next, similarly, we know that is a sequence counter is very important. Is to define the different sequence of time, T0, T1, T2. Okay, and if we go through that particular sequence, then it also define sequence. But another concept also there, that is selection inputs. They will also define which register need to operate. Okay, depend on that. So sequence inputs also defined S0, S1, S2. For example, that is 0, 1, 0 means 2. 2 means we have already discussed that 2 means what? That is a PC. The PC into bus. You see, whenever 0, 1, 0, that is 2. 2 means PC. PC data transfer to bus. Bus also receive and it will transfer to AR as per this instruction. Okay. So this is another concept. And similarly, transfer the content of the bus AR, and it is enabled to load into the AR. Okay, and T0 whenever go through another T1, then what happens? Very simple way, data transfer from or address data transfer from memory to IR, and PC will increase at T1 time. Okay, this is the basic concept. Another is another concept also we can define. Whenever that transfer data, then what happens? The content of memory transfer to the register, instruction register, when S2, S1, S0 is 1. If it is 1, then it will be activated and load into the instruction register. You see, instruction register, it will load. Okay, and PC increment, and increment also by PC, increment register also there, it is increased by PC. Okay, this is the basic concept. And after this, what happens? It will find the number of concept, like after this it is also defined, that is a T2. Up to T2 it is defined. After that execution will start. It will depend on the either using reference, memory reference, or register reference. They depend on that. And that is not now we will discuss, that is it will take more time. Another lectures I will tell that part. So at T3 time, actually up to here T2 is mentioned. You see, the T2 is mentioned, but T3 time also there to activate and decode that part, and also determine which type of instruction. It may be memory reference, may be register reference, or input output reference. That will define through another lectures. I will tell you another lectures, it will define. So in this way, 4 phases of instruction we have to cover, we have to consider whenever any instruction need to implement. Okay, thanks to all to watch these videos. Please subscribe my channel, and if you want to comment, you can comment it. Okay, thanks to all.